I hope screen is visible.
Yes, ma'am.
Yes, ma'am.
Okay, beta, thank you. So in last class, we have started Poisson distribution. When n is very large and p is very small, then we use Poisson distribution. And what is the formula? P of x, that is equal to e raised to power minus m into m raised to power x upon x factorial, where x is a discrete variable and it represented number of successes, right? If you need x is equal to 1, so we'll be putting here p x is equal to 1 e raised to power minus m into m power 1 upon n factorial. That will be the probability of, that will be the probability of when success is 1, right? When this discrete variable is equal to 1. What is m? M is the mean of Poisson distribution. That means average number of occurrence of event. And E is 2.7183, right? Mean and variance both are same for Poisson distribution, and formula is n into p. Mean and variance both are same for Poisson distribution, right? And for binomial distribution, we have done mean is n into p. For binomial distribution, mean was n into p and standard deviation was under root n p q, and variance is square of standard deviation. This is your standard deviation. We represent standard deviation with sigma and we represent the mean with mu. And this sigma square is your variance. So formula for variance in binomial distribution is equal to n into p into q, right? Where q can be written as 1 minus p because we know that p plus q is equal to 1. Let us discuss one example. A customer help center receives on an average 3.5 calls every hour. What is the probability that it will receive at most 4 calls every hour? Second part, what is the probability that it will receive at least 5 calls every hour? Right? You need to find the probability using, you need to find out the probability using Poisson distribution. Right? So you told me P x is equal to small x, whatever value we are assigning it. Formula is e raised to power minus m into m raised to power x upon x factorial. So now you tell me, in first part, we need to find out what? It will receive at most 4 calls every hour. So what is the meaning of this? You need to find out what? Yes, beta. We need to find out what? At most, what is the meaning of at most 4?
मैम
ज़्यादा
ज़्यादा
से
से ज़्यादा
ज़्यादा
4 होने चाहिए.
मैक्सिमम 4 होने चाहिए. तो we will be starting from where? X is equal to 0 plus x is equal to 1 plus x is equal to 2 means in every hour at most 4 calls. So what can happen? एक भी call नहीं, 1 call, 2 call, 3 call, 4 call, right? So you need to find out all the probabilities and add up to all. So for evaluation of this, P x is equal to 0. This is the probability of no call per hour. So for that, you will be applying the formula e raised to power minus m into m raised to power 0 divided by 0 factorial, right? So for evaluation of this, you need what? M. M is what? Mean. So according to this question, mean or average. So from this statement, average is what? 3.5. So mu or m. You can write it any way, and that is 3.5. Right? So you'll be putting here at the place of m 3.5, and then you can solve it. So at most 4 calls mean no call, 1 call, 2 call, 3 call, or 4 calls. So you will be writing like this: P x is equal to 0, x is equal to 1, 2, 3, and 4. And we need to add up all these, right? So for x is equal to 0, we have written the formula e raised to power minus m power 0. For x is equal to 1, you'll be writing here 1 upon 1 factorial. For 2, e raised to power minus m square upon 2 factorial. Similarly up to 4 factorial. E raised to power minus m power 0 upon 0 factorial. 0 factorial is 1. E raised to power minus m power 1 upon 1 factorial. Similarly for 2, 3, and 4. And then you'll be adding all the probabilities, right? Similarly, what is the probability that it will receive at least 5 calls every hour? What is the meaning of this?
कम
We
से
need
कम 5, बाकी 5 से ज़्यादा भी हो सकती हैं.
ज़्यादा भी हो सकती है. So we'll be considering what? P x is equal to 5 plus 6 plus 7 plus 8 and so on, right? So at least 5 means 5 call, 6 call, 7, 8 and so on. So it can be written as x greater than 5. X greater than equal to 5. So you will be representing it like this. Probability of x greater than equal to 5 is equal to x is equal to 5 or 6 or 7 or 8 or and so on. So when you'll be writing or, so we add the probabilities. So we are writing like this: x is greater than equal to 5, p x is equal to 5 plus p x is equal to 6 plus p x is equal to 7 and so on, right? And there are infinite many terms. So what will we do? We will evaluate it in other way. We know that probability, sum of all the probability when we are starting from x is equal to 0 plus probability of x is equal to 1 and up to whatever calls at the end of the hour we are getting, that is equal to 1, right? So we need what? X is equal to 1, x is equal to 2, x is equal to 3, and x is equal to 4, x is equal to 5, plus x is equal to 6 and so on. So I need what? I need from here up to last. So easiest way is what? Ki 1 minus, I can write this is equal to 1 minus probability of x is equal to 0 minus probability of x is equal to 1 minus probability of x is equal to 2, or I can take minus outside and plus plus x is equal to 3 and x is equal to 4. And this you have calculated already. This is what? probability of x less than equal to 4. Less than equal to 4. And this you have calculated in your previous question. Right? At most 4 calls means 0 plus 1 plus 2 plus 3 and plus 4. Right? So we can get the answer in the form of 1 minus p x less than equal to 4, and this we have calculated in previous part, so answer would be this. Right? In this way you can solve these type of question when at most and at least is asked. Now this is one more example. You will do it yourself. I have given you the answer as well as hint. Now come to the next, fitting a binomial distribution. The process of fitting of a binomial distribution is similar to the binomial distribution. In binomial distribution, we do have the formula like NCR, P power R, Q power R. So in that question, we need probability of success as well as probability of failure. So we need to find out N, and N is given to us, and we need to find out P. And from P, we will find Q. Because in that formula, NCR, P power R, Q power N minus R. So we need this P. So from given data, first task is evaluate P. And P, for finding the P, if data is given, so we find out first mean and then we go for this P. But when you need to apply the Poisson distribution, then there is no need to get the value of P, because formula is saying e raised to power minus m into m power x upon x factorial. So you are interested in only mean. So we will be finding the mean from the given data, and then we can find all the probabilities. So let us have an example. Or this is the relation beta. P naught is equal to n e raised to power minus m. If you are writing P naught means probability when x is equal to 0 for whole experiment, which is repeated n times, right? So formula is this. When you will be calculating P1, so formula was like capital N into e raised to power minus m into m power 1 upon 1 factorial. Right? So what you will do here, see n e की power minus m. This factor is replaced by P naught. So P1 can be written as P naught into m divided by 1. Right? This is the relation how you can relate these property. Similarly, if you are writing P2, so according to formula n e raised to power minus m into m square divided by 2 factorial. Right? So again, you'll be getting the same term n e raised to power minus m square. Okay, I'll be writing here P2 means when x is equal to 2, and that is equal to e raised to power minus m into m square divided by 2 factorial into n. So that can be written as if I'm writing in terms of P naught, so e raised to power minus m into m, n into e raised to power minus n, so I can write here P naught into m square by 2 factorial. Or if I'm writing in terms of P1, so it is P1 into m divided by 2. Right? So these are relationship between the probabilities which can be asked in MCQs. So it should be clear in your mind how we are writing this. Right now, P x is equal to 2. Formula is e raised to power minus m square by 2 factorial into capital N. Capital N means one experiment you have repeated n times. So e raised to power minus m into capital N, that is P naught. So if you want to write this in terms of P naught, so you'll be writing P naught m square by 2 factorial. If you want to write in terms of P1, So e raised to power minus n, e raised to power minus m, n e raised to power minus m into m, right? So, or you can say p naught into m is equal to p1. So you can write here p1 m upon 2 and so on. Now come to this question. Fit a Poisson distribution for the following data. This is your x. X is having value 0, 1, 2, 3, 4, and this is the frequency when x is equal to 0, x is equal to 1, 2, 3, and 4. Now you need to fit a Poisson distribution for this data. So first task is you need to find out its mean. And what is the formula for mean? Mean is equal to summation of fi xi upon summation of fi. This is the formula for mean. So you'll be making a table, writing x, f, and in another column x into f. Right? This is 0, 122, f into x is 0, 1, 60, 60 into 1 is 60, 2 into 15, 30, 3 into 2, 6, 4 into 1 is 4. Now summation of f, that is equal to 200, and summation of fx, that is equal to 106. Right? What is this? You have done in one experiment. In that experiment, you'll be having outcomes like 0, 1, 2, 3, 4. Right? And you have repeated that experiment 200 times. Same experiment 200 times. So when you are performing that experiment in 200 times, so for this 0 frequency was 122, for 1 frequency was 60, and likewise for 3, 4. This is your experimental value or observed value. Now you need to fit here your Poisson distribution, that is theoretical distribution. You are applying the formula and calculating it, right? For this, you will be finding this mean. So summation of fi xi divided by summation of fi. After solving, you'll be getting mean is equal to 0.5. So you have mean, and now you need to find out probability of x is equal to 0. Similarly, probability of x is equal to 1 and 2, 3, 4. Right? Whatever is required in your question. So you'll be using the formula e raised to power minus m. M is what? 0.5. So 0.5. And then 0.5 m power x. X is what? 0 divided by 0 factorial. This is for single experiment. But when you are repeating it 200 times, so you will be multiplying this with 200. Right? Similarly, x is equal to 1, 200 into e raised to power minus 0.5 into 0.5 divided by 1 factorial. Right? Similarly for 2, similarly for 3 and 4. So you will be using this formula. Theoretical frequency for R successes, e raised to power minus 0.5, 0.5 power R. R is equal to 0, 1, 2, 3, 4. So this is your theoretical frequency 121, 61, 15, 2 and 0. Right? And this was your experimental frequency 122, 60, 15, 2 and 1. So only there is a difference of 1, 1. So you can say that this Poisson distribution is suitable for the given data. Right? Any doubt? Till here, any doubt? Okay. Now come to the next, that is normal distribution, right? We have done binomial distribution and Poisson distribution. We have done binomial distribution as well as Poisson distribution. Binomial and Poisson distribution both are discrete distribution. And next, normal and exponential distribution both are continuous distribution. So today we'll be starting one continuous distribution, that is normal distribution, right? So this is your normal curve. If I'm talking about the height, and height is starting from not exactly 0, some value and up to going 195, right? So this is your interval. X is taking the value within this interval. When X is taking value in interval, then you say that that random variable is continuous random variable, right? So normal distribution is, it is widely used model for the distribution of a random variable, that is normal distribution. Usually we use it in various situations. We are using this normal distribution, and this is your normal curve, and this data is also having following normal curve. So when we are talking about the continuous random variable, so in previous class we have done, when we are using the continuous random variable, so we do have one function that is known as probability density function. In case of continuous random variable, probability is given by probability density function, right? And this is your probability density function in case of normal distribution. Normal distribution, probability density function is given by this, right? If I'm asking you, find the probability, this x is less than equal to 2 and greater than equal to 1. So what will you do? You will be integrating this. What is the formula for evaluating this? 1 to fx dx. And now this is your fx over here, fx dx, which is difficult to solve every time because this is a bit complicated fx. So every time when you need to find out the probability, you need to solve this integral, which is difficult task. So for sake of evaluation or to make this calculation easy, what is done? We have converted this continuous random variable into standardized normal variable, right? We will convert this normal random continuous variable into standardized normal variable, and then we evaluated this integral. And after evaluating this integral, we do have one calculated table. So in normal distribution, you never evaluate these integration. You get the values from the table, right? I will provide the table in this PPT only. So that table is actually come from integration of this function. So to reduce our calculation, we can use or we can refer that table. So this is the density function for normal distribution. This, the normal random variable with mu is equal to 0, mean is 0, and variance is 1 is called a standard normal random variable. And standard normal random variable is denoted as z. X is your continuous random variable, right? And in that case, you do have a function fx, which are displayed in previous PPT. So we cannot calculate this every time. So what we do for our calculation, we convert this normal random variable into standardized normal variable, right? And this z would be equal to x minus mu upon sigma. This x is your actual random variable and this is your standardized normal variable. So whenever in question x would be given, mu and sigma is given, you will be converting this random variable into standardized random variable. And then for the probability, finding the probability of this less than equal to z, we will be referring the table. We will not do integration because after doing integration, that value is given in the table. So this is your standardized normal variable, capital X minus mu upon sigma. So it is denoted by this probability z less than equal to z. Less than equal to z, it is a cumulative distribution function, right? And for distribution function, we do have this formula, infinity minus infinity to x, fx dx. We have done it yesterday in case of continuous random variable. Right? So what is this basically? This is area under curve from minus infinity to x, whatever point is you are taking here. So similarly is this. Now, properties of normal distribution. Normal curve is a bell shaped. You already observed it that this is your normal curve. So it is like bell shaped. Symmetrical in its appearance. It is symmetrical about this. This is the straight line. This is mean. It is symmetrical about mean. Curve is asymptotic to the base on either side and range is unlimited or infinite in both the direction. See, it will never touch this axis. It will never touch in this axis. When the curve goes parallel to the axis and don't touch this axis, then this is known as asymptotic. Curve is asymptotic. It will go parallelly, but it never touch the axis. So it is infinite in the both directions. Since there is a one maximum point, there is a one maximum point in this curve, the normal curve is unimodal. It is named as unimodal because it has only one maximum point. Property number 4, in normal distribution, mean, median and mode, all three coincide. All three are same, right? So this we have discussed already. If you need to find out the probability of this x less than equal to x, so you will be converting this into the standardized normal variable and you will be writing it p z less than equal to z. Z is standard normal under variable and this value is obtained by standardizing x. Now, area under standard normal curve. We know that now integral a to b fx dx represent area under curve. So if I'm saying p z is greater than equal to 0 and less than equal to small z, and let's say this z is having value 1.25, right? So ultimately we are doing the integration starting from 0 and going up to 1.25, and that fx for normal distribution which we have discussed or which I had displayed in first slide. So this fx is what? This is fx now. This curve is defined by this fx, right? And you will be integrating it from 0 to 1.25. So you will be integrating from 0 to 1.25. So ultimately what you'll be getting? You'll be getting area under curve, area under this curve, and this fx is defined by that probability density function of normal distribution. So you need to concentrate only this. If you are finding the probability this, it means you need to find out the area under curve from 0 to this. And you will be getting value of table, value of probability z is equal to 1.25 from the table, and that is given by this 0.3944. How we will see this value in table? You will be getting the value of z 1.2 in this column and 0.5, 1, 0.1, 0.2, 0.3, 0.4, 0.5 in this form table will be given. So you will be getting 1.2 from here and 0.5 from here, and where these values are intersecting, that will be the value of 1.25. I'll show you in table, right? So basically under this area under this curve, total area would be 1 because we know that this is the probability. Minus infinity to infinity, area under curve is 1. So half of this area, it would be 0.5. This left hand area total is 0.5 and this is again 0.5, right? Because it is symmetrical about mean. So half area this and half area is this. And total is 1, right? So now let us see. This is the table given to you. And in previous question, you need the value of 1.25. So what will we do? We will be finding 1.2 here. This is 1.2. And 0.5. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So this row and this column. So value is 0.3944, right? So you will be finding this value 1.2 at 0.5. So this will be your value. Similarly, if you want to find out 2.11, find the value of 2.11. So how you will start? This is 2.1 and you need to find out at 0.1 over here. So their intersection point is this. So value would be 0.4826. Similarly, if I'm asking you 3.26, tell me the value of 3.26. Yes, beta. Get the value of 3.26. You'll be
0.4994.
0.4992. Yes, this is 3.2 and sixth column 0, 1, 2, 3, 4, 5, 6. This is 0.4994, right? So please get a picture of the in this table, because in next when we'll be solving the question, so you will be telling me the value from this table, right? Please click the picture. Got the picture? Okay. Now come to the next. Find the area between z is equal to minus 0.44 and z is equal to 2.23. So you need to find out the area. This is your z-axis and I am drawing this normal curve over here, right? So z is minus 0.44. So you will be writing, highlighting this point on the left side, minus 0.44, and highlight this point here, 2.23. So you need the area, this area. Find the area between, so you will be finding value of this area, right now? So you will be writing it like point minus 0.4420. 0. This point is your 0. Mu is equal to 0. This is mean. Minus 0.4420 plus 0 to 2.23. But minus 0.4420 plus 0 to 2.23. Because it is area, तो जितना एरिया यहाँ होगा उतना ही एरिया इस साइड होगा. So there is no matter कि you will be looking the positive values in the table, not negative value, because that is the area. If you'll be taking on the left hand side, so you will be considering that area on left hand side. If it is positive sign, then you will be converting that area on the right hand side. Simple, because area is area. So you will be writing required area is equal to probability minus 0.44 less than equal to z less than equal to 0 plus probability z is greater than 0 and less than equal to 2.23. Now you will be writing it in the positive one, 0 to 0.44. Okay, because it is area, no matter with the sign. Now, what do you need, beta? You need to find out this 0.44. So look in the table, 0.4, 0.4 in fourth column. Tell me, beta, what will be the value? And similarly for next also 2.2 for 3. Tell me both values.
Ma'am, 0.1700.
0.1700.
1700.
It is for 0.44, beta.
Yes, ma'am.
Okay. Now go for this 2.2 in third column. 2.2 in third column. Yes, Satvik is telling me. Aditya, you please check. What was it, beta? 0.48. I cannot read this chat again. 4837 probably. I think he has written this.
0.4868.
68. Okay.
And 3. 7171. Sorry, ma'am.
0.4871.
Yes, ma'am.
Okay. 0.4871. Satvik, has you written the same? If yes, then it's fine. If not, okay. Right. So, very right, beta. This value is 0.1700 and this is 0.871. Then you'll be adding it. So, answer is 0.6571. Right? And this I have already told you, ki minus infinity to infinity means total area is 1 and 0 to infinity is 0.5. Similarly, 0 minus infinity to 0 is again 0.5. Now, find the area to the right of z is equal to minus 1.25. Now, you will be telling me the answer. This is your bell curve. A z is equal to minus 1.25. And you need to find out the area to the right of this. You need to find out all this area. Now tell me how we can find out this area. Tell me, beta, how we can find this area. Again, we will be dividing into two parts now. Minus 1.25 to 0 and then 0 to infinity. So you know that what is the area of this portion? Right side of the 0. Complete area right side of the 0. This area is what?
0.5.
5, right? So it is 0.5. Now you need to find out this. You tell me what will be the value, bacha. We will not bother for negative sign. I'll be writing it in the positive term. Now tell me what will be the answer. You need the value of this. Check from table. 1.2 in. Yes, Aditya, bolo bache.
0.3944.
0.3942.
3944.
Okay. And this area we do have
4, ma'am.
4 beta.
4.
Chalo, now let's see. Correct. Very right. 0.3944 this area, and this we do know. We do have this value is always 0.5. So answer is this 0.8944. Area right to this is equal to 0.8944. I hope it is clear how to calculate it. Now, this is for you. Just take 1 minute and let me know what will be the answer. You need to find out left of this. Again, I'm drawing this bell curve for you. And let's say this point is minus 0.4. So you need to find out left of this. So left of this means you need to find out this area. Now do it and let me know what will be the answer. And how.
Ma'am, may I?
Yes, beta.
0.1554.
0.1554. कैसे बच्चे? How? No issue, Satwik. No problem, beta. Anyone else? Isha, Yashika, Akash, Karnik, anyone, please give me the answer. It's very simple. You need to find out area to the left, z is equal to 0.4. You know that, na? This total area is what? This total area is what? 0.5. Right ना? तो 0 पॉइंट ये वाला एरिया कहाँ से आएगा आपके पास? अब ना बेटा, maybe it's your network issue. You can rejoin. Okay? I hope screen is visible to everyone, na? Is screen visible?
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you. So you need to find out this area. तो ये एरिया फाइंड आउट करने के लिए हम क्या करेंगे? Are you getting or not, beta? It's not so hard. It's very easy. This total, you know that is 0.5. And if you know the value of this area, so you will be subtracting this area from 0.5 and you will be getting your answer. Right now? Yes or no, beta?
Yes, ma'am.
Then tell me what will be the value. See, when I'm saying here 1.25,
0.3446.
answer? Okay, let's check.
Yes, ma'am.
See, you need to find out the area minus infinity to minus 0.4. So minus infinity to minus 0.4. How can I calculate it? In out of this total, I'll be subtracting this, and this area is what? 0 to 0.4. So minus infinity to 0 is 0.5 minus 0.4 to 0. इतना सा area मुझे find out करना है. Because it is in the negative term, I'll be writing it in the positive term. This total is 0.5, 0.5 minus this. So you will be getting the value of 0.4 from the table, and answer is this. Is it the same answer, Niharika, you are getting?
Yes, ma'am.
Good, beta. So why are you not speaking? You should speak, beta, whether it is wrong or right. At
Okay,
least for
ma'am.
me. ठीक है? At least मेरे लिए कि so that I can get कि at least few of students है, those are getting. Okay? Is it clear, everyone? You need to find out area left to this point. When I'm saying this is 1.2, it means the area is starting from 0 and giving the value up to 1.2. So this total is 0.5 and I need to subtract this area. Okay? This is in the negative direction. I will be writing it in the positive direction, and from table I'll be getting this value 0.4. So I'm subtracting this area for 0.5 and it will give you the required area. Right? So these were the example when the question is directly in terms of Z. You need to find out the area. Now question is in the form of statement. It means X is given to you, then you need to convert X, that is normal variable, into standardized normal variable, that is Z. So let us have this example. If height of 1,000 students in the university campus closely follows a normal distribution with average height 69 inches, average means mean is given to you. So mean is 69 and standard deviation is 2.5. So sigma is 2.5. How many students are there of height at least 6 feet or 72 inches and other part height between 65 to 72 inches? Right? So first we'll be concentrating on this. Mu is equal to 69, sigma is equal to 2.5, and this you need to find out. At least means 72 and more than 72. So you will be finding capital X greater than equal to 72. Right? This is your X. So capital X, I'm writing 72. First, you need to convert this normal variable into standardized normal variable, and that is z is equal to capital X minus mu upon sigma. Capital Z is equal to X minus mu upon sigma. X is 72, mu is 69, sigma is 2.5. Just calculate and let me know what value of Z you are getting. Do it, hurry up.
1.2.
1.2. Let us check. 1.2. So standardized normal variable Z is X minus mu upon sigma, 72 minus 69 upon 2.5, 1.2, right? So it means you need to find out probability of Z greater than equal to 1.2, right? So if I'm drawing this standard curve, this, and this is the point 1.2, and you need at least 6 na, तो means 1.2 से greater. So ये सारा area you need to find out. So now you can do, please try to find out this area. It will give you the probability. Similar case na, you know this complete right hand side is 0.5 and you will be subtracting this area from 0.5. Solve it and let me know what you are getting.
0.1151.
0.11. This is the answer, beta.
Yes, ma'am.
0.1151.
51.
Aditya, getting same, beta.
तो कैलकुलेट कर रहा हूँ अभी.
करो बच्चे करो. हरिंदर जी, सात्विक.
यस मैम, मैं कैलकुलेट कर रहा हूँ.
करो करो करो. टेल मी. Same. Satvik is getting probably same.
यस मैम, सेम.
Same? Okay. Now let's check it. 0.5 minus 0.3849, that is equal to 0.1151. Right? So number of students with at least 6 feet height, ये आपके पास probability आई. So you'll be multiplying this with the number of students into 1000. And answer is 115. So this number of students having height at least 6 feet. Right? Good, Akash, if you're getting the same. Number of students with at least 6 feet, that is 115. Right? So now you'll be trying the second question. Now you need to find out the number of students having height between 65 to 72 inches. So in that case means you need to get the value of 2z corresponding to 2x. Now one value of x is 65 and another value of x is equal to 72. So from here z is equal to 65 x minus mu upon sigma. Get one z from here and get this z you have calculated, I think. 72 minus 69 upon 2.5. Right? Get the value of this z1. Let's say I am saying it is z1 and this is z2.
Minus 1.6.
This is minus 1.6 and this was
1.2.
1.2. Right? So now it means you need to find out the probability z less than equal to 1.2 and greater than equal to minus 1.6. So now you will be again drawing this curve and this is your 1.2 and this is your minus 1.6. So you need to find out in between. So you will be getting this area. Now get this area. and then we'll be multiplying that probability with 1000. Get it?
Ma'am, 0.8301.
0.8301. Good, Satwik is also getting the same. Right, beta? So you have calculated this Z1, Z2. You need to find out in between. So you'll be getting this area minus 1.620 and 0 to 1.2. So writing in the positive terms, and answer would be this. Very right, beta. 0.8301. So now to find the number of students, you'll be multiplying this probability with 1000, and answer is 830. Right? So 830 students are there having height between 65 to 72 inches. Done? I hope this question is clear. This was the question when x is given and then you are converting that x into standardized normal variable, that is z, and then for getting the probability for z, you will be referring to the table. Now come to the next. Find mean and standard deviation of normal distribution in which grades 35 and 63 correspond to standard scores minus 1.48 and 1.23 respectively. These are grades and these are standard scores. Standard score means this is your Z1 and this would be your Z2, and this would be your x1 and this would be your x2. So you need to find out mean and standard deviation. So can I write like this? Z1 is equal to x1 minus mu upon sigma, and this Z1 is minus 1.48 is equal to 35. This is corresponding to 35 minus mu upon sigma. Similarly, from the second, Z2 1.23 is equal to corresponding to 63. 63 minus mu upon sigma. Right? So from these two equations, you'll be getting two equations in mu and sigma. So simply you can solve this. Like I'm writing 35 minus mu is equal to minus 1.48 sigma. Similarly, 63 minus mu upon 1.23 sigma. So you can subtract them, get the value of sigma and then corresponding mu. Two equation, two variable, you can solve it. Right? One equation, second equation, solve it for mu and sigma. Next, normal distribution fitting to the given data. For this fitting, we need what? First, we calculate the mean and standard deviation. See, if data is given to you, so you will be getting the mean and standard deviation for this fitting, and then you'll be using this. It is quite lengthy parted distribution ka. You just have the idea how to fit the data. So it is not in your syllabus basically. So likewise, you are doing the fitting in binomial and Poisson. Similarly, we can do for the normal distribution. But the difference is in that case, we will be using only mean and probability. So here you need to find out the standard deviation also, and in the similar way you can calculate it, right? So that's all for today, Vita. Thank you. Any doubt, then please ask.